So now that we have the debug system working, I want to focus next on our transition system, our transition component, and how we're going to make this all work. Now, in the spirit of the game, the next screen that I would like to code out is the shop or the cave that Link runs into in the very beginning. If you've played The Legend of Zelda, which I assume you have if you're watching this video, you know that there's supposed to be a shop right here, the place where Link is running into. There should be a shop or a cave. Link goes downstairs, he grabs a sword, and then his adventure begins. I want to program out this room. So to do that, let's go back to our code editor. We're going to be doing a few things here. It's a bit complicated, so stay with me. Let's scroll down to the load screen function within the game class, and we see that right now we're handling the tile if it's a number, if it's a string, but how are we going to handle doors or transition spaces, right? And the way we're going to do that is we're going to make our load screen function detect if it's an object. So we're going to just write some logic. Type of tile is equal to object. And we're going to use objects for a variety of things. The first thing that we're going to use it for is for a door that Link will walk into. So when Link walks into the door, he goes down the stairs and then you see him in the shop. So we're going to have a variety of different kinds of objects. Well, how are we going to denote if the object is a door, or perhaps it's a wall that's destructible, like the side of the cave that you can blow up to get into the final level? You place a bomb on the rock, it blows up, then it reveals a door. We need to have a way to determine what is what. So I'm going to just show you how this object is supposed to look. And the first property that I'm going to illustrate to you is the type property. And it's going to be a string, and it's going to have a few different values. The first thing is door. The second possible value would be like an actionable tile. So imagine that rock being blown up. We want to be able to commit or do an action on the tile to have some kind of event occur. And I think for now that's good. We're going to be using the door type right now. And if we go to the screen file, go to this 0, the 1 0 that's between the two 1 strings, and let's create an object. So we're going to put in this object type door. This is going to let our load screen function know that it's a door. The second property that's going to be in this object here is tile. Now, some objects are going to have different tiles. As I said before, if you know the game, you've blown up holes in the side of the mountain, in the sides of other objects where at first perhaps it was a rock or a bush, and then after you completed an action against it, like you put a bomb on the rock or you used the candle to light the bush on fire, it turned into a door of some sorts or a staircase. So we need to know what the tile is supposed to be, and if we have a replacement tile, we can handle that later. But for right now, this tile is going to be very simple. It's just going to be a door. So let's go into our asset folder. And we need to pick out where door is. And in this folder, if you go to overworld, I already put it in the actionable tiles folder as a 0.png. So it's going to just be 0. And we can string number. Let's go and add this into our object. Tile equals 0. Now, the next two properties I'm going to have in this object are coefficient x and coefficient y. And they're going to be used to know where to put Link on the preceding screen. So, for example, if Link is supposed to enter on the bottom, we want to put, I don't know, 12 or 11y and then 6 or 7x or somewhere in the middle. And we're going to use these values like 6 or 7 or 11 and multiply it by the tile size. So that way he's at the appropriate distance from both the x-axis and the y-axis as well. So it's going to be like this: co-x number, co-y number. So I'm going to try, let's see, co-x 9 and co-y 11. Or maybe co-y10. We'll see. When he comes on screen, we'll know for certain if that was correct. And the last property, but certainly not least of this object, is going to be the property that tells us what screen it is that we need to load up. So for this property, let's go with shop, or let's call it screen, and we can make it a string. It could also be a number as well, especially when you make a lot of these screens. But for right now, I kind of want to keep it a string so it's very verbose. We can see it and immediately know what it is. We'll bring it up here. Screen shop. And let's go make our transition component. Our transition component is going to take 3 properties. It's going to take this screen, this co-x, and this co-y. Let's export the transition component. Now let's go to our registry and make sure that we can account for it here. So follow the pattern. Transition. Const component. So now that the registry will recognize the transition component, we need to create the transition system, and then we'll also add it to the registry. So how the transition system is going to work is we're going to have these transition tiles that will not have a sprite, but they will exist at certain points of our screen. So when there's a collision between the player and one of these transition tiles, we will have some event occur. Let's go to our system, and it's going to be similar to how we program the collision system. We're actually going to be using pretty much the same formula to determine if there is a collision between the player and one of these transition spaces. So transition system extends system. It's going to take a position and transition. Those are the only 2 components that it needs, because some transition spaces will not have sprites. This one will have a sprite. However, when Link runs up or to the left, when he runs off the screen because he's going to the area that's above him, those spaces will not have a sprite. Have an update function. We're going to be passing as well the player into here, so we can set that as a parameter of the function. And very similarly to this, you know what? We can just pretty much copy this, which is nice. There's going to be some logic that's different inside, of course. It's not going to have anything to do with movement, but we can copy this and use that. The player will never have a transition component, so we don't need this. We don't need movement because I'm not so concerned about waiting until the player is really inside of the transition space to act. So we can get rid of the movement from this argument, from this logic statement rather. And then we don't need these 2 logic statements. Okay. So similar, not exactly the same, but very similar. We're still using this logic structure right here. Now for right now, I'm okay with just doing a console log in the transition space to just make sure that the player actually got in there. We're not quite ready to test it yet. We still need some things to set up. So go back to your registry. We're going to add the transition system. And I need to export the transition system though. That's why my code editor is making it yellow, because it's actually it's not able to be found. I'm going to import it. My editor helped me with that. Great. Now let's go into game, the game class on index.js. And just like every single system we've made so far, let's do add system, transition system. And then we'll call the update function. We'll put it right here. Transition system update. Don't forget to pass this player. And I'll even put it right there at the bottom. Great. Now let's stay within the game class and let's go to the load screen function. So right now we need to create this entity that will have this transition component. So let's determine first that it is a door. Let's keep in mind that we may have other kinds of objects. So let's get the type from the tile. So const type tile. If type is equal to door, then let's do our logic. And what is the logic? Well, we need to pull out from this tile the co-x, co-y, and the screen. So now let's pull it out. So const co-x, co-y, screen from tile. And let's create a dummy transition component from it. So const dummy transition component is equal to name transition value co-x, co-y screen. And then we'll push this into that array that we're going to be using. And now let's go to the transition system. And just to make it easy, let's just console.log this entities out to just make sure that it's being properly created. Oh, looks like we're getting an error. It looks like it's right at where that door should be. It says that it cannot render or fail to execute draw image because it's an object. And you know why? Because we actually did not give the render system the name of the file that it has to render. Right now, it's actually just receiving an object. So what we want to do, it's a little counterintuitive, but thanks to JavaScript being an easy language to work with, what I now want to do is I want to simply take this tile, because this tile that we got was an object. Now let's just set it to the 0 value. So that way, when it gets down here to components push, it'll push in a value that the render system can use. So we're literally deleting the whole object and setting this tile variable to 0 as a string. So it went from an object to a number/string. Let's see if that worked. Oh, assignment to a constant variable. It does not like that. So tile can't be a constant. Let's change that. Now this time it said it's getting the 0, so that was successful. However, it's still not getting the door value. That's because this is the wrong path. So we actually need to set a different path for this. So let's go back. And the door is at assets overworld actionable tiles. So there's one more folder it needs to go down. And we forgot the set path, so that makes sense. Actionable tiles. Let's see now if it's, yeah, see now it's rendering. Very good. And if we look in our console log, that this is successfully creating the entity with the transition component. That's great. As shop, co-x, co-y, fantastic. Let's also see if there's collision between the player and the transition tile. Yep. You see that in the transition space. And then if I walk out, so it is working. It's successfully colliding with the player. The next thing that we need to do is we need to create some kind of way of handling events. Now, there's a lot of methodologies on how to handle events, and that could be a whole video series in and of itself. But right now, I want to focus on a easy and useful way to handle this without getting too complex. So what we can do is we need to create a queue of events that will occur first in, first out kind of setup. However, JavaScript, being the easy and simple language that it is, we can actually just use an array to handle this kind of functionality. So what I'm going to do is I'm going to create this event bus, and I'm going to set it just to a normal array. And on every single update, what's going to happen is we're going to check if there are any events. So const event this event bus, and we're going to get, since we're doing a first in first out methodology, we actually want to get the event at the very end of the array, because we're going to be popping events off, and the pop comes from the back, and it's also a faster way to do this when thinking about the time complexity of operations. So this event bus dot length -1. So this will always give us the last element within the array. If there is an event, let's do something. Our event is going to have two kinds of arguments. So I'm going to illustrate what this is going to look like. Or sorry, two kinds of properties. It is a object, and it's going to have the args property. And args is going to be a object that has its own properties as well. So args is going to look like this. It's going to have a whole transition component in it. So all the properties that a transition component has, as well as the event time. So the event time, we're going to use that to compare against the game time to determine if we want to fire this event or not. Because later on, we're going to do some programming where we're going to have delayed events. So for example, Link drops a bomb. The bomb doesn't detonate immediately. It takes a second or two. However, we want to have this event, the explosion, queued up, so that way when it's ready to explode, it will explode when we want it to. The next property that we're going to have is actually going to be a function. So we're going to pass into this object the function, the kind of event that we want to occur. So for the bomb example, that was the explosion. And for the transition event, we're going to load up a new screen. Let's go to the transition system. And in this bracket, let's get the transition component, of entity. And what we're going to do is we're going to pass in the event bus. So event bus, we're going to create the event. And it's going to have the same properties we just described. So it's going to have args. We'll pass in transition and all of the properties that it has. We're going to duplicate them. And we're going to set event time ourself for 0. And the function is going to be reload new screen. That's going to be our event object. Now let's pass, or let's push this event into our event bus. Now we'll go back to our event example, and I'm going to create another logic structure. Let's pull out the args first, and we can even pull out the function as well. So if args event time is less than or equal to this game time, call the function, and we can just do this. And we'll pass in the args themselves, because as we're going to see, we haven't made the function yet. We're going to be able to pull out all the arguments from this args object. And then finally, let us get rid of this event by calling this event bus pop. And something I just noticed as well that I need to address is I need to actually move this render system down into the render function just to separate the priorities and to be clear about what it is that each thing is doing. We can also move the animation system down as well. It doesn't really change how our game operates, but that's fine. Undefined push, that's fine that we're getting that error. It's not ready to be tested yet. Let's go, and we're going to create a new function, and it's going to be load new screen. And what it's going to take is a transition component. So if you look back in the system, you see that we pass a transition component into the args, right? And then here we pass the args into the function. Just imagine that this function says load new screen, because it's going to handle a variety of functions in the future. But for right now, all you need to know is that it's handling the load new screen function, and it's taking args, and args look like this. It looks like co-x, co-y, and screen. So that's really what's happening here. And we're even going to destructure the arguments. So I'm going to do co-x, co-y, and screen. We also get event time too, but it's not mandatory. We're not going to use that in this function, so we don't really need those values. And the first thing that we should think about is when we're reloading or we're loading a new screen, we already have a screen that's on, that's being displayed, that's being rendered, it's being animated. There's values that exist there. We have entities that are taking up memory in our computer. So what we need to do is we need to actually remove all the entities that already currently exist. So remember before when we created that update function in registry, and I had said that we would be using another property called kill all entities or something along that nature to get rid of the entities? Well, now we're going to be actually creating this property in the registry. So if we go up, we're going to create the property, and it's going to be this entities to be let's say removed. So when we're thinking about removing entities, we need to think about where it is that they live. And they live in several places, namely the systems that have these entities in their this.entities array. So what we're going to need to do is we need to cycle through all of the systems and push all of the entities within the system to the this entities to be removed. And then later, what we're going to do is we're going to cycle through all these entities to be removed, and we're going to essentially delete them from the system. So let's go down, and I'm going to create a new function. Let's call it remove all entities. And what we're going to do, we have already every system within this object. So in order for us to loop through the this system's property, we need to use the object.values, and we're going to pass in this system so we can loop through it. And then we're going to go into each system. You know what? Actually, what I would like to do, and we're going to be using the this entities to be removed property later on in this video series. What I'm going to do right now, instead of making the registry do it, a very simple way to handle this would simply to be this, or I could say system entities equal to empty array. And it should remove all of the entities within the system. Okay, so that was easy. Let's go back to our load new screen function in the game class, and let's just call this. So this registry, remove all entities. That's easy. So now theoretically we've removed all entities. Now we need to load in the new screen. So we already have a function that's handling load screen. We're already doing that, right? So I think it would be prudent for us to just call this function again at the end. However, if you look, this load screen function has an object that it takes. It takes a screen object. So we need to pass it a load screen object. So what this is going to do, we're going to determine which screen we need to use based on this screen value. So I'm going to set a let new screen object, and I'm going to not going to initialize it. And I'm going to use a switch case on screen. Switch. There we go. So if this is shop, we're going to set new screen object to the shop. We will create the shop soon, but first, before we do that, I do want to do a little debugging just to make sure that we're on the right path and everything is working as it should be. What I do want to do is I want to go to systems and get rid of this console.log because I want to have a clear console because we're going to check for any errors that may be occurring. Then go to your game. Let's just hit the transition space, and it seems that we are getting an error. Cannot read properties of undefined reading push at system 144. So I think that's probably because, are we passing event bus to transition system? I have a feeling that we are not, and we are not. This event bus, and let's pass this load screen function as well. Let's try that again. See what we get. Scream is not defined. Well, it shouldn't be because I've never written a variable named scream. 135. Yes, that makes sense. Okay. It's at least getting to this switch case right here. Now, if we do this one more time, I think we're going to see that it can't read undefined reading screen. It's okay that we're getting that error. It's occurring down here in the load screen function. Yeah, it's trying to load this, and that's fine because we're not actually passing it the object yet. So this screen object's undefined, obviously, because we're calling load screen. There's nothing there. So that's fine. That's fine. What we need to do now, though, to test the next part of this is we need to actually create the shop screen. So I've pulled up a image of the shop screen that we're attempting to replicate, and we can use this as a model just like the last screen that we modeled, and we can do it similar to. So why don't we open up the shop, and we'll pull out, oh, not that one, not yet. We'll pull out all of the images that we need to begin. This one's fairly simple. Just a black rock, or a dark rock and a black space. The black space is within tiles, while the rock is within collidables. We're also going to have the old man act as a collidable as well. I can give us some more room. I can do that. Similarly to how we did this last time, const shop, make that an object, and now the asset path is going to be assets shop. The screen is just like last time, it's going to be an array. And to keep it simple, I'm actually going to just at first copy and paste this, and I just want to change one or two things just to make it obvious that we're loading in the proper screen. So I'm going to just place some random boulders in the middle of the shop object to help us see what's going on. Let's export shop and make these small. For load new screen, if new screen object, or if screen is equal to shop, we'll set it to shop. And then we'll use this new screen object as a parameter, and we're going to pass it into this load screen. Cool. So now, actually, for the sake of making this not error, I'm actually going to keep it the same asset path because we don't have all of the same PNG files in the shop that we do as we do in the overworld. So I'm going to keep this overworld, but make a note, change this to shop. I know I won't forget, but let's go check it now. Refresh, files are saved. Oh, and it looks like it worked. Very cool, because now it changed. Those two ugly boulders are in the middle of our map. And we'll go back to our code. And actually, we'll open this up. So we'll change this to shop. And let's use the tiles that I have put to the bottom of the screen to create this shop. To begin, I think this looks pretty good. All of these are ones, right? Now that we're using the shop, this is the file that we're actually targeting. And type a string is a collidable, so the type is correct, the name is correct. Let's just change these top two zeros to ones because there is no open space there. I'm going to move these down to the bottom. There we go. Okay. Let's get rid of this object because we do not have any kind of special tile there. That is just another rock. This 2 should be a 1 because, again, it corresponds to that one PNG that we have at the bottom. No open space. Good, good. Get rid of the 2. This actually, so I'm actually going to make this a 0 because if we look, it seems that we only have 2 rows of rocks. There are not 3 rows, there are only 2 rows. And, it's only 2 full rows of rocks, and then there's 2 columns that go down the side. So this 1 should be a 0 as well. And a lot of these ones need to be zeros now, so this one should be a 0. This one should be a 2. These 2s are in the middle. And that old man we have, and I'm going to fix this in a second, but that old man is also a collidable, so we're going to actually put him in the middle as a string. I'm going to just put him as a 0 string in the middle. Make this a 0. Make these zeros. And at the very bottom, there's 2 rows of rocks. So many of these are 1s as well. 1. We'll make the open space at the moment right here. And then the rest of these 5s are 1s. These 0s are 1s. Okay. No, that should be a string 0. I just wasn't sure because it seemed like this was a little bit longer than it should have been. Didn't want to be missing a tile. And that looks pretty good. Now, when I attempt to render this on screen, currently Link will not appear. He's actually, as an entity, he's being removed, so he won't exist anymore. However, we're going to handle that in a moment, but let's go to our game. Let's see if we get any errors. Let's see, we get an error. It says collidables 4 PNG not found. Well, that makes sense. 4 and 5. Ah, I left these as 4 and 5 right here. That should be 1. That should also be a 1. Let's try that again. Okay, no errors now. And let me open this up so we can see completely. Put this to the side. Okay, so we have our screen. Old man is a little off-centered, but that's fine. Now what we want to do is we would like to, let's create Link first. We're still missing the fire, but I would like to create Link. We're going here, we're going to use the coefficient X and the coefficient Y. And we're going to use these values in a new function called create player. So before, we were kind of just creating the player right in the initialization phase. But we need a special kind of function to actually handle Link, because not only is Link going to be initialized at the very beginning of the game, but we're actually going to create and delete Link every time a new screen is loading. So what we will do is create a create player function. I can even put it right below the load screen function. Create player is equal to so this function is going to handle the 2 scenarios I just mentioned, Link being initialized at the very beginning of the game, as well as him transitioning between screens. So what we want to do is if this player, so meaning the player already exists, right? If this player, we can just take all of the player's components and simply just like copy and paste it, right? So what I'm going to do is I'm going to say let new components equal to an empty array. And if this player, let's get the components player, or let's make this an object rather. And what we want to do now is we want to iterate through the components object to push all the components that exist within this player into the new components array. So let's do object.values, pass components, and then for each component, new components, push component. Then at the end of this, let's console.log out new components. And let's call this create player. The function's not finished yet, but let's just test it. New components. Okay. So it seems that every component was passed properly. The only thing that we want to change is the position component. And we want to change the position component based on the co-x, co-y values. So we can do this right inside this for loop. And what we're going to do is we're going to do if component type is equal to position, then we're going to take the component X and set it equal to co-X times tile size, and component Y equal to co-Y times tile size. Let's just put a console.log in here. Position is being changed. Let's see in our game. Seems like it didn't get through. Maybe that's because the name of the property itself is component type, not type. Also console.log out the component just to be doubly sure. Position is being changed. Very good. Okay. Let me make this smaller because it's interfering with the rendering of the screen. Okay. Now that we have this working, we need to handle the other possibility as well, which is link just being initialized. So we're going to do an else statement, else, and we're simply going to take these values for link, dummy collision, dummy sprite, dummy position. We're going to move them down here. Going to take this player. Also going to just delete this console.log and any of the other trash that we don't need. Now, get rid of this. And we can just do components, or new components, I should say, new components, push, dummy, or new components, we can even just set it equal. Dummy position, dummy collision, dummy position, dummy sprite, dummy movement, link animation. Pass in new components into this as an argument. And also, I'll push this as well. Oh, but I only need one of these. Make sure to not do that in the for loop. There we go. Now let's see how this works. Oh, and I almost forgot. We need to call this function, of course, at the beginning. So this needs to be called in initialization. So this create player. And I don't think that should create any bugs, even if, since we're passing without any parameters. I think it should still be okay, though. I don't think we will have that problem. Let's go here. So we are getting an error. Uncalled. Cannot destructure property X of player.components.position as it is undefined. Okay, we'll go back. So what I think is happening here, since it said it can't destructure the properties from src rect, I think what the issue is that we can't exactly, and yes, of course we can't take the component that the player currently has and push it into a new components array and expect that the create entity function is going to properly understand it, because the argument that create entity function takes, it's not the same as how the data structure of the component is actually set up. So if you remember, we have a name, which is a string, and then we have a value, which is a complex object. So how this is going wrong is we actually need to pass the component type, and then we can actually just destructure the component, and that should work. Because what we're going to have in this component, it's going to be something like, if it's a movement component, for example, it's going to look like component type, which is string, x, y, height, width. Or sorry, that's position component. I don't know if that's what I said. That's the position component. And yes, we're going to put it in here. We're going to take the component type and use it as the name. It will also be in here. However, when we are creating a component, it doesn't matter in JavaScript if we have an extra property that's not being assigned anywhere. So it doesn't matter if we have an extra parameter like component type. It's going to pick up on these 4 properties and initialize our position component. Okay. So let's go back and see what we got. I think this is still going to error, but let's just check. And it looks like we're having an undefined path. So if I'm correct, I think that's because link, we're also not setting the sprite component properly either. So if component type is equal to sprite, because if you remember, the sprite component takes a path argument. However, it's not its own property within the component. So what we need to do is we actually need to, let me fix that. Take this component path and let's set it manually ourselves. Component sprite src, and I believe that should work. Let's go back to our game. Very good. And now we have Link appearing here where he should. And even better is he's colliding with all the collidables that we've rendered on the screen.